Thank you for your interest in my little course I created to share some of my understanding of how basic principles of statistical analysis can be understood, visualized, and simplified as much as possible. We will start with the first Google Colab notebook, which is available in the comments to the video. And normally, if you have a Google account like myself, you can easily run the code, which is in Python, cell by cell. You don't need much of understanding of how the code and the language of programming works. You can just replicate a few minor modifications that I do during my explanation. So the first notebook, which is called Plots Explained, is needed for a more clear understanding what is the histogram representation of the data. I propose you to execute the first cell and to observe the outcome. It takes some time for initializing the environment. It's perfectly okay. But at the end, you will have to observe something like this. What did we do is precisely generating the randomly varying data of 50 elements. And there are just two options of the value of the data. It is either 1 or 2, and it is random. This is the simplest representation when each data point is represented at different positions on the x-axis, and on y, this is the amplitude, either 1 or 2. You can repeat the same cell and you will observe now a different pattern because it is random. Then you have other two figures, second and the third, which is identical in form but slightly different in the values. What is it? This is a histogram with the number of observations of value 1 and of value 2. It should be something about 23 and 27, perhaps. On the other plot, you see also two bars, but with the percentage of the distribution between the two values, between the two potential values which the data can have. If you run it another time, you will see that there will be about the same outcome with some slight variation because of the randomness of our data. And this slight variation is very important, as you will see in the subsequent videos. Now we will look at a different type of distribution, which is a uniform distribution. Well, this one is also uniform, but with just two options. Now we have a number of different values ranging from 1 to 2. So you see that it can be almost anything between the two extremes, and the chances are not precisely the same, but randomly varying between the extremes. There is no favoriteness, there is no predominant value which the data can demonstrate. You can run generator again and again, and you will see a different pattern. All those variations are purely random. Though it might look like there is something in it, there is really nothing except randomness. And the best way to prove it is to increase, which is very easy, to increase a few times the number of samples. With a greater number of samples, you will see a much flatter distribution. And if you increase the number of samples even more, 10 times more, the uniformity of the distribution becomes even more clear. And now we will look at a different distribution, which is very important for us because this is what we can often observe in the nature and in the society, which is a normal distribution. We run the cell 3, and we can see that there is a higher chance to observe our data in the middle of the range, which is normal for normal distribution. Again, you can say that this looks pretty noisy with no clear preference for the center of the range. You see there are a few peaks here and there is something around this spot. But again, you can increase many times the number of samples and you will see a much more clear representation of the data distribution with the maximum probability to observe the central data values and with less and less chances to observe extreme values of the data.